example, looking at a political contribution example. Um, read through here. We've got political action committees. That doesn't look too important. The FEC has reported financial information for 556 PACs that operated during the 2020-2021 election cycle. We've got a random selection, so this is our sample of 30 PACs, result in the following statistics. So they give us these: average $251,000, standard deviation. Whoa, that's a big standard deviation. But this is our data. That's what it resulted in. Use this sample data to construct a 96% confidence interval for the mean amount of money raised by all leadership PACs during 2011 2012 election cycle and answer the following questions. Okay, for those years. What type of inference distribution should you use, or did you use? Well, again, we've got, we look here, the standard deviation is an S. That means it came from a sample. That means we're going to use a T distribution. Or let's see, what did it say here? A T interval. You could just say a T interval, T distribution. Either one's okay, but you could just copy down from the calculator. I'll put both. Now, since we have 30 PACs, that's large enough that you could do a Z and we should get pretty much the same, but it's right on the borderline. So let's just be as accurate as we can. We're going to go do a T. Why did we use this? Again, because the standard deviation comes from a sample. Something like that, right? When it comes from a sample, we always use the t-test. State your confidence interval with the mean. So now it's time to calculate it. We're doing the t-interval. Okay, we're going to input the statistics. Sample size, we have our sample mean is 251, 854.23. And then our sample standard deviation is given up here of 521,130. Some gave a lot, some gave a little. A lot of variation in what was contributed. And we had 30 PACs in our sample, so that's our N. Put that in there. Confidence level we were asked to do is a 96, so 0.96. Go to the next. Here's our critical value, standard of error, margin of error. Those are all good stuff, but we can also just come to the next one, and here's all the information we need. So the plus or minus goes with the plus or minus in here. So we're going to head and write in 251, 854. And notice that came right from here. That was the mean. And we're adding or subtracting the margin of error, which is 204, 593. So what is our confidence interval? Here it is right here. We got the lower ends 47,261. That end 41,261.7. But yeah, you could round it. I don't know. You could put that in there too. 70 cents, right? 456,447. Just write them in. And the chart here, the normal distribution curve here, is to kind of help us out. What is our mean? Our mean is 251, 854. And the upper end of our interval is 456,447. The lower end of our interval is 47. I had a 40. Didn't quite get that right. Let me clear that up a little bit. 47 to 61. I know it's just you're rewriting similar information, but this helps you see what are we really getting. We're 90. This is all. If we took a lot of samples, this is the interval that the means would lie in. So again, another way to explain this is if we took 100 samples, 96 of those samples would have a mean in between these values. Or we can just go with the standard. We are 96% certain, confident, certain. Problem if you change your words too many times, you can't spell what you're certain. That the true mean of the population is between 47,261 and we could put units by putting in the dollars and 456,447. So that was that one. That's really all you're going to need to do. Confidence interval stated. And what does it mean? The true mean, because again, we don't really know the mean of the population of all these 556 packs. We're just dealing off of a sample, but the statistics lets us be pretty confident, 96% confidence that's between these two values.